going to start an interesting topic called machine learning. Machine learning applied to supply chain management. Okay. The first method that we are going to look at is called support vector machines. Okay. This method is used to separate datasets by distance metrics. So imagine you have data from two different processes. You want to know which data points belong to which process, depending on the values of the process. Okay? So this method calculates the distances between the points and separates the data and puts those data together that are closer to each other. Okay. In order to do so, we need to perform certain tasks. First, we need to install several programs, and for this you need to write this code. Pip install matplotlib and pip install Seaborn. Okay. The first one is called NumPy. It's called NumPy. It's numerical Python. It uses numerical array calculation. SciPy means scientific Python. Matplotlib is used to create graphical representations. And Seaborn is something, it's a program that is used to create graphical representation plus create datasets and represent them. So I press Shift Enter, and it tells me requirement already satisfied because I already have all the packages installed. When you do it, it will install them. Okay. Now it's telling me that I already have them all installed, so I don't need to do nothing but to import them. So now I open the packages. Import NumPy as NP means that every time I open, I call NP, the kernel understands NumPy. Okay, so I am opening the NumPy library. Within matplotlib I call pyplot and I call it plt. So this means again every time I called plt, the kernel understands call matplotlib.pyplot. Then from SciPy, I don't want everything, I just want to import the stats, okay, the statistical part of scientific Python, and from Seaborn I only want to import SNS. Okay. Just for the record, if you want to investigate more about any of this, you just go to Google and say Introduction NumPy Python. Okay. And you can go maybe to W3 schools. And here you have a lot of information about what you can do with Python. Okay, a lot of examples and how to create data distributions and stuff like that. Okay, just use Google, and or if you want to introduction SciPy Python is also very interesting what you can do with SciPy. You can get I don't know, you can get a lot of things being shown. Let me get an example somewhere. As I said, just Google, for those of you interested, Google can help you. You can do many things, permutations, combinations, you can solve linear algebra. You can do basically anything you want, anything that is in your mind, you can solve it with these packages. We now focus on supply chain management, and for that we are going to generate first with these packages some data set using sklearn. Okay, sklearn is a part of well, if I don't have sklearn, I need sklearn, so I also need to import it on pip install sklearn. Sklearn is to create and perform machine learning. That's why it's called learn. Okay. Pip install sklearn, and then here I say import sklearn. Whenever it shows this star here, it means that it's thinking. Okay, so it's just saying all the time requirement already satisfied, and now sklearn I didn't have, so it's installing it, and then I say generate some data set. Okay, I go from sklearn dot datasets dot samples generator import make blobs. Okay, this means the sub package datasets within sklearn has a function called samples generator, in which we can create datasets made of points. It's called blobs, but in reality there are points. Okay, so I just import it. What happens here? make blobs. What is wrong? Did I write something wrong? Simplest generator. I wrote something wrong. No. What happens here? I did it this morning. What do I need? Whenever I get a it's wrong, so they change it, so now I need to write only this. Okay, only from datasets. There is no samples generator anymore. Has a function in which, so now it works. So you see, whenever you get a mistake, just get the mistake. Okay, whenever you get a mistake, just go to the error and Google it, okay? Because chances are that people have had this problem before, so the help is usually there. We just found it here. Anyway, so once we have imported our make blobs, we generate the data. Now we generate the data set. And for that, I called X and Y, X big and Y small. And then I say make blobs of what? So first I call the samples. How many points do I want? Let's say 100. Okay. I'm trying to go slowly. First, we define the number of points, the sample. Then we get the centers, 2. This means centers is the number of products, different products, okay, and the number of classes. Let me say classes here. And the next one, random state is 0. This is just a randomization, and then the cluster standard deviation. Okay, how big should be the standard deviation of the data. Okay. Then I press Shift Enter, and it is giving me something wrong. I go to Google again. I think I have the old version. Let's get it away, this random state. Okay, now I have the data, and now I print the data or represent the data graphically. With matplotlib.pyplot. We are calling it a PLT, and then a scatter plot, X, the first column of X, okay, then the second column of X, and the color is going to be given by Y. Okay, we'll leave it like that. Okay, you see two data sets with standard deviation 0.6 and cluster. I have two data sets, 100 points and standard deviation 0.6 each. I say S equals 100. That's the size of the blobs. What we are doing now here is, let me insert another no, that was too fast. I can print it again, so print X. What we have done here, you see with X, we have created two columns, two centers, that each has a standard deviation of 0.6, and Y is the class. Okay, print Y is the class, either 0 or 1, because we have two centers. That's why when we write PLT, when we write the graphical representation, what are we doing? We are plotting on the horizontal axis the first column of X, which is X, 0, and in the vertical axis the second column of X, which is X, 1, and now then we say the color C is given by the value of Y, 0 or 1. We can also choose a color palette, autumn, so that it's prettier. S is just the size of the blob, so I'll take it away. And with autumn looks prettier. So I can also call the, I don't know, RGB, blue. Probably gives a mistake, but I don't know. I can choose from different color sets. Okay, I can say blue green. Okay, blue green red, and that gives me different colors. Okay, I like the autumn because it's yellow and red and can be very well separated. So here, what happens now if we increase the standard deviation? If we say, let's say we have a standard deviation of 0.8, this means that the data set is going to be more spreaded. Okay, so you see we have a higher spread. Okay, so now imagine the yellow data set, the data points of the yellow data set is one product, or one process or one customer, and the red is other customer. Okay, but you don't know it yet. So you just don't know it yet. So you can say, as of today, intuitively, this is the way it looks like. Okay, and we don't know how to. So this is like this, but in reality, I'm trying to make a case. Okay, in reality, we do not know what are the colors yet. Okay, so we don't know which point belongs to which class. And that's why we use a so-called linear support vector machines, okay, which is going to draw this algorithm is going to try to draw a separation line between the two data sets, which is optimal, meaning that it has a maximal distance to all points. Okay, so how do we represent this? How do we represent this? So for a 2D data set, a two-dimensional data set, we can do it by hand, but for many dimensions, so many data sets, it is more difficult to separate the data. How can we do it? Well, let me paint these lines before I continue. NP lean space -1 or minus -1, no, -15 to 15. Okay, and then I say PLT scatter, the same as before. Then I say also please plot no, I don't want to plot that, and I want to plot the lines. Okay, I want to plot the lines that separate the data set. So for M, B in let's say let's say let me do something, wait a minute. Let's say 5, 1, 9, 0.5, 1.6, just some data, okay, some numbers, -0.2 to 2.9. The for loop, plot me please 3 lines along the data set. We know that the equation of a line is x times the slope plus b, and I want that with a line. And then I say plt the x limit minus 1, minus 15, comma 15. Okay? So I have painted, or 4 and 4. I have painted some lines that try to separate the data set. Okay, I can change now the parameters and say, let's say I can paint here a -4 and then see what happens. Okay, or minus 0.4 and see what happens. So I try to separate the two data sets, but it's kind of difficult to find the right solution. Okay. So what will happen now is that we are going to try to separate the data set using the technique of drawing a line and finding the distances between this line and the data points. So we use support vector machines to calculate the line that best separates the data set. So for that we need a sklearn, because it's machine learning, import SVC, okay, support vector classifier. Support vector classifier, and we call the model called SVC. Our kernel is linear, and yeah, and then we say model x, y fit. Okay, so apply the kernel to our model. Good. So now we have our model, it's plotted, and now we can plot the results. We can plot the results of the model. How do I do it? Moment. What is the best way? So we first define a function that is going to represent the decision function that has a variable called model, and it's going to plot me a line of support. This specific line of code is not relevant for the exam. Okay, this code, I'm going to paint it, but it's not relevant for the exam. Okay, I just need it. I explain what it does, but it's not is not relevant. Because it doesn't add anything, it's just a graphic representation. So the levels and the line style. And then if plot is stuck, then the model should go in. Good. Okay, it should work. Plot support is not defined, it should be in. Okay. So what this does is that it is going to plot me the two lines, okay? And is going to take the data set of the model, and it's going to take the support vectors of the model that we just fitted, okay? So it just is going to plot me the best lines in a limit from the limit, the lower limit to the upper limit. It's going to point to plot 30 points. So now I copy another line of code. As I said, this is not relevant for the exam. It's just important that you understand what it does, but not. I will not ask it in the exam. So it gives a mistake here. So for me, it's important to get the concept clear. So in the first one, as you can see here, we plotted only 60 points. Okay, in the graphic on the left, we plotted only 60 points. On the right one, we plotted 120. I can also plot 300. Doesn't matter. Okay, it goes quite fast. As you see, we have with this first function, plot SVC decision function, we are plotting the decision lines that best separate the data set. Okay. And we are also plotting the support lines up and down. That's why it's helping me with the support vectors. Okay. These lines are the best separators of our two data sets, yellow below and red up. Okay, because they have the maximum distance to all the data that we have. So whenever we find new data, if we have a point that is up this line, then we know it's red. If we have new data and it's below the line, we know it's from the product or from the process, yellow. Okay. So we're looking for separators. Of course, in 2 dimensions, it's easy. In when it gets with more dimensions, when you have many data sets, it's kind of more difficult. Okay, so this is possible to do it to do this is possible with a linear kernel. You see here always the kernel is linear. So we are separating with lines. But what happens if the dataset cannot be separated with lines? What happens if the dataset has a circular non-linear shape? Okay. Then we need to use other kernel. Let me paint, let's create some non-linear data set. Just like we created before the linear data set with make blobs, okay? With sklearn dataset, make blobs. Now we're going to create circles. So we go from sklearn datasets, import, make circles. Okay, so these are data that are distributed in circles. Equals, make circles with 100 points factor. This is the standard deviation, the middle point, and the noise is the standard deviation. So and now we say let me paint them. Okay, and now so we can plot them like we did plot them before. PLT, scatter, blah blah. Okay, so now you see our data is like that. It's distributed in circles. And now we try to separate this data with a linear kernel, so painting lines within, okay, CLF. It's our support vector machines. Kernel, let's say, is linear. And we say fit x, y. And we tell him again, please plot me the data, but also plot the decision function. Plot support. Okay, so now we have tried to plot the we have plotted the data, and now also we have plotted the decision function of CLF of our model fitting. We have called it CLF. CLF coming from the classifier linear function. Okay, CLF, let me put it like this. CLF means classifier linear function. But our linear classifier is obviously not succeeding in separating the data yellow and blue and red. Okay, so our linear classifier is not succeeding in separating the data through a separating the data successfully. Okay, so it's just not succeeding. We need to define another kernel, and this kernel is called the radial basis function, which basically creates circles. The equation of a circle is numpy, then exponential of minus x square. This is square is the double x, the double asterisk, and then sum 1. Okay, x squared plus 1. We have our radial basics function. And now we create another kernel. Create another kernel. Based on the radial basis function. So our radial basis function equals support vector machines kernel equal radial basis function we give him a certain approximation level, and then we say RBF dot fit x comma y. Okay, it approximates, and now let me paint the whole thing. PLT dot scatter x double point comma 0 comma x double point comma 1. The color is Y as before. The size of the blobs is 50 and CMAP is autumn. So if I paint that, I get the same, okay? But we are trying to paint the result. Plot support vector classificator, decision function RBF. Okay, if I paint that, you see our classificator has classified successfully. Okay? Does it make sense? So whenever I find a new point that is outside the not dotted line, the continuous line, it's red, we know it's red, and whenever we find another point that it's within, we know it's yellow. I can, of course, change this kernel, okay? I can say, let's say, I'm going to make quadratic, not quadratic, but cubic. Good, well, I get also a good approximation. If I make it linear, then it just doesn't work. Wait, and 6. Let me make it logarithmic, see what happens. also works. Okay. No, it doesn't work. Exponential square. How do I get it logarithmic? NumPy logarithm log 10 log of x. Now I'm a little bit curious. Let me just try one thing. I want to try. Invalid encounter in y. Y. I say x square. It also works. Okay, it's interesting just to change the kernel. But you see now we were able to separate the data set, whereas before with the linear kernel it was not possible. Okay. This makes sense. Have any questions? Okay, maybe one question is how can I prepare for the exam? Okay. Well, in the exam, I might ask you. Okay, I give you. I might ask. Please generate a data set that is linear with 50 samples, 2 centers, and a standard deviation of 0.3. So you need to write me this and this. And then once you have created it, please give me a way to plot it. You need to write this. And then once you plot it, then give me a kernel that is linear that can separate the data. You need to give me this. Okay? As I said, this is not in the exam. Or I can ask, please give me, create a data set with 200 points that, and please make sure that you represent them so that the data are distributed in circles. Okay? So I get this. You need to write this code. Because you need to write it in a piece of paper, the best way to prepare for the exam is just to write. Okay, just what I'm doing right now in the lecture, just to write it yourself, not to copy my code and try to understand it, but to write it. Because whenever you make a mistake and instead of decision here you write decision with 2s or with 3s or whatever, it gives you a mistake. Okay, because it doesn't understand it. It obliges you to look at what your mistake is. So I put here 3s, so that's why it doesn't understand it. But if I put just 1s, then it understands it. And you can see here that the linear kernel does not separate correctly the data. Okay, so I can ask you, please create me some data set distributed in circles and create a linear kernel that does not separate them properly. So I could do that, or you should write this, okay? Or create me a radial basis function that creates a good separator for circular data. So you need to give me this. Okay. Okay. If you want to investigate more about sklearn, you can go here to this website and get more examples. Okay, it's a very good website to learn. Zack just goes and explains and gives you a bunch of examples. You have here hundreds of examples of you can do, for instance, face recognition with support vector machines. Okay, super interesting stuff. This is how, by the way, this is how your iPhone recognizes your face with support vector machines, because it's very cheap computational wise. Anyway, I'm just trying to open the door for you to learn machine learning. Okay, this is just, of course, these are just basics, but if you are interested, now you have the tools to start diving into the shit. Okay, so now we get to decision trees, and these are used to separation of many dimensional data sets. Let's create a data set with more than 2 centers. Okay, we do that with sklearn, datasets, import, make blobs, and x, y, and then say make blobs, number of samples equals 300, and centers equals 4 for centers, cluster standard deviation equals 0.1 or no 1.0, and then I just paint the shit. I scatter x 0.0 comma x big comma 1 comma c equals y comma s equals 50. This is the size and the C map. Now I'm going to use rainbow to get pretty colors. Okay, I can also say atom. I don't like it so much, so let's say I get rainbow. Okay, so now I get 4 different colors, and impossible to separate this with just with one line. Okay, just or circles, impossible. So we need to separate the space. Okay, so imagine these are 4 different products that you have, and the horizontal axis is one KPI, the vertical axis is a different KPI, and now you need to separate the space. Okay, and you do that with sklearn also with the decision tree classifier. Okay, from sklearn tree import decision tree classifier. Then the tree is going to be the decision tree classifier, and now we say fit x comma y, and that's basically it. Okay, so you see, if I ask you in the exam, please create me a data set with 400 samples and 4 centers and standard deviation 1 and plot it, you write me this. And then I ask you, please write me how to classify this data with a decision tree, you write this. Okay. In order to visualize what this does, okay, this visualization is not relevant for the exam, okay, but so that we understand what the whole thing does, I have prepared some code. I'm going to copy paste, okay, and yeah, you don't need to. I mean, first we're going to plot the training points, then we're going to fit the estimator. But I don't ask you to learn this code because it's too much. I just want to show you what the visualization does. Okay, so we just create a function that visualizes our decision tree classifier, and I hope I didn't make any mistake. And then we can apply this function, visualize classifier. And then our model is called tree. Okay, we have here our model is called tree. And I guess no, we have called it differently, so we need to call it the decision tree classifier, just as we did before, and then we say comma x comma y. And you see what it does. Okay, it's just separating the space with 4 areas. Okay, it's just basically is creating a decision tree, is separating our data set into areas and telling us that if we go over a certain y level, vertical level, then we get from red to violet. If we get to the right, we get to green. If we go below, we get to blue, and then we get to red. So it's just separating our data set. Okay? And this helps us separate areas of products. I don't know if you remember from logistics, or I don't know other lectures, something called ABC XYZ analysis. Remember this? Where we described, we describe several strategies depending on what? On the amount of value of products, which could be now the x-axis, and the amount of or the frequency of these products. Okay, the ABC XYZ analysis can be done very easily, super fast with decision trees. So instead of having 4 centers, let's say we have 9 centers. Suck. Okay, so it gets complicated, but for our model, it is done in, I mean, faster than you can look. Imagine you need to do this by hand. Okay. Of course, all these images can be then printed and put to use in presentations, in management decisions, and so on and so forth. So this is very, very cool. I strongly recommend that you get into machine learning because it's just the future. Okay, well, it's not the future, it's just the present. Okay, any questions? You can go to also this website and get very many examples. Of course, you can deduce that I get my questions for the exam from these Google searches. Okay. So you see how data sets can be separated, different data points. You can download the Python source code, okay, or just copy paste it, investigate what the whole thing does. And so I hope you find this super interesting, as I do. Anyway, questions please. Give you some homework. Find two-dimensional data set. X two columns and Y classes, just like we had it. Find or create. That is distributed linearly. Apply decision tree classifier to it and visualize the results. You can send me your results. No, not two-dimensional, three-dimensional. Here, 3 columns. I give you a little hint, decision tree, classifier, 3 classes, Python. Okay, so here you can find multi-class problem, blah, 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 just study, 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 okay? You can send me your results per email as usual or WhatsApp, okay? Questions?